Hi, welcome to this video where we're going to have a look at the fundamentals of business analytics or data analytics. So one of the key things to understand regarding data analytics or data science or business analytics is that we're using quantitative research. Okay, so we're going to be using analysis which is essentially quantitative in nature. Now, the reason that we use quantitative analytics is because fundamentally we're being driven by the desire for objectivity. Okay, so we're looking for evidence which we feel is objective to some degree. In practice, in practical application, we're not looking for the level of objectivity that you might find in science, but it's a similar sort of principle. So if we go right back to early science, what made science different and what made it special was that it based its theories on observation. Okay, so people tried to develop theories about the world based upon the evidence that they were seeing in front of them, rather than what had happened previously, where theories and views of things were developed based upon religious texts or simply the assertions of powerful people. So the argument that we should base our theories on evidence was a revolutionary statement, and actually many of the early scientists were put in prison for that. Now, observation requires reliable measurement, okay, and that means well-defined units. So, for example, time measured in seconds. Okay, so of course, it's no good me asking you, how long will it take to do that, and you say 46, if you don't tell me what the units are. Otherwise it means nothing. So well-produced observations can be relatively objective, and what we mean by that is that they can be relatively independent of the researcher. So it's not my opinion, it's the evidence is showing, and my theory is based upon that evidence. And that's why mathematics became the language of science, because scientific theories were expressed through the language of mathematics. And that's what we're looking for in data analytics. Now, we're not sort of, like I said before, trying to achieve the same level of accuracy and certainty that we would find in science. So, for example, in a practical sense, if I ask you, how long does it take to drive to London, then you're not asking me to come up with a prediction to the nearest second. You're going to be looking for some kind of a prediction, probably to the nearest 10 to 15 minutes. And so, in practice, when we're doing analytics to support managers and management decisions, we don't need high levels of accuracy always. Normally, we're trying to find a level of accuracy which is appropriate for the situation that we find ourselves in. Now, the next thing to sort of think about is, okay, so if data analytics requires reliable observation, we need to start asking ourselves, what can we actually measure? And this is a huge problem, because many of the important features of running a business, or many of the important pieces of information, actually can't be measured reliably. Okay, and so therefore a different type of research is going to be appropriate. And that's why qualitative research methods are so useful in management, because we can't always use quantitative analytics. But we often can use quantitative analytics, and when we can do it, it does provide an extra level of objectivity. So what are the key elements of the research process or the analytics process? Well, we normally start with a research question or a client problem. So it might be something that we're trying to understand, or something that we're trying to address. Then we need to get some data in order to support our analysis, and then we can do our data analysis, which is the fun bit. Now, Whether you're going to collect your own data or use someone else's, it's vital to have a clear understanding of the question. Okay, now it normally takes a bit of time to get to that sort of question. Normally we need to do a bit of problem structuring. Normally we need to do a little bit of exploration. Sometimes we need to look at the data that we have to see what's possible, because often we're using existing data rather than data that we're actually going to go out and collect. So normally it takes a bit of time to get to that research question. It often takes a bit of experience as well to get there. But it's vital, because quantitative research may not be appropriate, and the data that you have might not be sufficient to do what you're trying to do. So it often takes time and experience to get a clear statement of the research question. Now, getting your data, now it seems so simple, but data collection can often be the most difficult aspect of good research. Certainly, I've been involved in many data analytics projects, and this is often the bit of the project which is the most difficult, and the one that I get most nervous about, because often organizations don't have good data management. Often data has been collected and managed by information system departments who don't really have a clear understanding of what analytics might be possible. So often the data is not quite in the right format, or it's not quite reliable enough for what we want to do. Or it's being collected by people who don't really have the time or inclination to collect the data carefully, and the reality is that often the data analysis is not done by them, and doesn't feel like it's for them, so they're not as careful as they might be. Now, if you're collecting your own data, then the design of the collection tool requires care. And collection can be time consuming and expensive. Things like questionnaires, finding out, going and collecting data. It takes a lot of time and it's a lot of effort. So which is why, most of the time, analysts like myself will actually be using other people's data. So that's data that's already been collected by somebody else. Now it can be excellent. So for example, if you're looking at, transactions on websites, where customers have bought things on websites using credit cards and accounts, that data is going to be absolutely excellent, because that type of financial data has to be right. So you'll have all the data, timings, who the purchases are, how much it was, what the products were. It'll be really good. But sometimes data is patchy, and sometimes it's difficult to obtain. So certainly I've worked for companies who had data on databases who actually didn't know how to access that data, because the databases were bespoke, and they required special types of software to actually access them, and they didn't have the expertise. And like I said before, sometimes it's in the wrong format. You should always check the quality. Often it's worse than people think, and then you have to make a decision, whether you can go ahead with your analysis. Now, often you can, as long as you understand what the problems are, or what the inaccuracies are, because like I said before, often you're not required to produce absolutely precise numbers, because you're trying to give managers a feeling for which direction they should be going in, and you might be able to do that even if the data is not fantastic. Now, one of the important things with data analytics is to learn the language of data analytics, because often data analytics can sound very foreign and sophisticated and difficult, but actually it's just the language that people are using. So here's a few useful terms. So cases or subjects, so they are the guinea pigs in your study, if you like. They are the people or the things that you're focusing on, you're collecting data on. Variables are simply what you measure about the guinea pigs. Okay, so for example, if your guinea pigs are customers, you might be interested in their age, gender, location, salary, all sorts of things related to them. And each one of those things that you collect data on is a variable. Data, that's the actual numbers in your table. Sample, so that's a selection of a population. So often in data analytics, we don't collect data on everybody in the population because we don't need to. We can collect a sample of that population, and that sample will give us sufficient accuracy to make generalizations about the population. So the population refers to all of the people that you're interested in. And inference or infer is making statements about all guinea pigs in England based on your findings from the sample, okay, or generalizing. Okay, so that's the logic behind taking samples. So for example, we take a sample of guinea pigs and we find that 75% of the guinea pigs eat grass, and then we generalize that to the whole population. Okay, now those of you who know guinea pigs will know that's not true because all guinea pigs love grass, but there we go. So what does data look like? Well, these days we tend to pretty much always interact with data through a spreadsheet. It might be Microsoft Excel, for example, or it might be you might be using Google Docs. But it's basically going to look like this, where you've got the variables in the columns, okay, going up and down, and you've got the cases or the subjects in the rows, and so the data for each case will be in that row, and here we've got 14 cases, all of them are universities, and we've got 4 variables, so we've got tuition, rent, survival, and then we've got total. So notice that total is a different type of variable. It's a calculated variable. It's simply the adding up tuition, rent, and survival. So in summary, the data relates to universities. There are 14 cases and 4 variables. This is a sample of a population of over 100 universities. Now we may want to summarize the data with statistics. So statistics is a way of trying to say something useful about the data that we have on the cases that we're interested in. So it might be averages, it might be charts, it might be histograms. Now, it's also important to recognize that there are different types of variables out there. So, for example, if your variable can only have 2 possible values, so for example, maybe with gender, it might be male or female, or it might be that customers might be members or non-members. We call that variable a dichotomous variable because that column can only contain zeros or ones. That's normally how we do it. Now, sometimes variables contain values which can't be ranked in terms of size or can't be ordered. So, for example, we call that variable categorical or nominal. So, for example, if you're asking people for reasons why they go to the gym, you might have answers like relaxation, fitness, lose weight, okay, and other reasons. Now, those answers can't be ranked in terms of size or ordered. They're just discrete words. So, for example, you might be doing analysis on different brands of toothpaste. So your variable might be brand, and then in there might be sort of Colgate, and of course the data in that column can't be ordered in any way. Now, sometimes the values can be ordered or ranked. Now, we call it the variable ordinal if it's not numeric. So, for example, if we're asking people how many times they went to the gym, and the answers were daily, or 3 or 4 times a week, or once per week, or once per month. Notice these can be ordered in terms of size, but they're not numerical. So these are not proper numbers, they're just different answers. Now, the variable is discrete if it is numeric, but it can only have integer values. So, for example, the number of customers has to be an integer value. You can't have 2.5 customers. There's no such thing as a 0.5 of a customer. Now the variable is continuous if it's numeric and it has proper scientific units. So for example, distance in meters, area, weight. These are proper scientific measures with proper scientific units. So yes, we can have 1.5 meters. We can actually have 1.523 meters. So we can have proper measurement, and that type of variable is going to be the best type of variable for data analytics. Now, in terms of types of data analysts, there's lots of different ways of categorizing analytics. One way which I find useful is to think of univariate analysis, which is where you're just looking at one variable, one column, to see how the data in that column varies. And we might use things like frequency tables, charts, measures of central tendency like mean or average, and dispersion. Now we'll talk about that in another video. Bivariate analysis, where we're looking at two variables together to see if there's a relationship with them. So we might be looking to see if we can predict something based upon knowing something. So for example, we might want to predict sales based upon advertising spend. So we might want to try and understand how much money we should be spending on advertising, for example. Now multivariate is very similar to bivariate, but it just means we're using more than two variables, and that can get quite complicated, but I will talk about that another time. Now a model is a way of trying to summarize the relationship between two variables. So for example, here we've got data on advertising spend and sales, and we can see that for this particular business, the more they spend on advertising, the more sales they have, which is what you'd expect. And we can see that as advertising spend goes up, then sales goes up. And we can actually see that relationship looks to have a linear nature. So we can actually put a straight line through that data and say that straight line is actually summarizing the nature of that relationship. And that would be a linear model that we would use to do that. So models are a way of summarizing the relationship between two variables. If there is a relationship, if there isn't a relationship, then we can't do anything. We just have to say there's no clear relationship. Now metrics are also very popular. Now metrics are measurements representing the performance levels of important variables within an organization. So we will often have key performance indicators, where a set of key measurements which we feel gives us an overview of the present performance of the organization. And we might also use metrics to identify problems within the organization. And key metrics are often put onto some kind of a dashboard, like that in the picture there, which kind of shows us all the key metrics which relate to the business. Now this is really, really useful because it allows us to easily monitor if the business is performing well. If there are issues arising in the business, we should be able to spot that on the dashboard. But we also have to be very, very careful, because sometimes businesses can start to chase the metrics, and actually that can start to be not good for the business as a whole, because obviously this is a simplification of the real performance of the organization, so we do have to be very careful. So if you want an analogy for models and metrics, you might think of a sat-nav. It is a simplified model of the real world to help you navigate on the road. So a sat-nav presents you with a model which is useful in finding your way, but obviously it's a simplification. Now a speedometer measures velocity, which is an important metric used when driving a car. Okay, so you're driving your car along the road, you look down, you see the speed you're doing. That's a really important metric to tell you, are you obeying speed limits, but also is your speed appropriate to the road that you're on. So that's a little sort of way of thinking about the difference between models and metrics. Okay, so that's a quick introduction to data analytics. We'll go into looking at this in more detail in other videos. Okay, thanks a lot.